Welcome back, everybody. Here in our next lesson, we are going to be focusing on finding the surface area of pyramids. So we'll define what those are, how they're different from prisms, and how we can use a formula to help us with this problem. Of course, as always, make sure you have a pencil and paper ready to take notes, copy down formulas, and whatnot, as we will be finding the surface area of our pyramid using those formulas, and that'll be your objective by the time we're done. Let's go ahead and get into it. First things first, we will predominantly be focusing on something called a regular pyramid here. And a regular pyramid is a pyramid whose base is a regular polygon. The lateral faces this time are triangles. In our last lesson on prisms, the lateral faces were rectangles. The height of each triangle is something that we call a slant height of the pyramid, and that'll make more sense when you see a picture here in a little bit. Before we get onto that, though, going back to the first statement here, it says a regular pyramid is a pyramid whose base is a regular polygon. When we describe something as a regular polygon, that means that the polygon has side lengths that are all equal and interior angle measures that are also all equal or congruent to each other. So when you think of a regular polygon, you would think of shapes like squares, a traditional triangle, a hexagon, pentagon, the normal shapes that you're used to seeing with equivalent side lengths. Keeping that in mind, here we see our first pyramids, and it says the surface area S of a pyramid is the sum of the areas of the base and the lateral faces. This sounds almost completely identical to what we talked about, finding the surface area of prisms, with one small but important difference. Notice it says finding the sum of the areas of the base. I'll stop there. Pyramids only have one base. It's obvious looking at the picture, of course. In our last lesson on prisms, though, remember that prisms have two congruent bases. Pyramids only have one. Whatever that base is, that determines what type of pyramid it is. For example, here, the base is a square, so we would call this a square pyramid. If the base was a triangle, we would call it a triangular pyramid, and so on. But that'll help us not only name them, but identify what that base should be. Notice again, though, that the lateral faces are triangles here, meaning when you go to find the area of all of those surfaces, those lateral faces, we'll make sure to use the formula 1/2 times base times height to calculate that. Before we continue, I will encourage you to make sure you write down our formula here, which says to find S, or the surface area, you're going to take the area of the base plus the area of the lateral faces, and that is close to the most precise version of this formula that we're actually going to end up using. And we'll start here with example 1 and finding the surface area of a square pyramid. So on the left, you can see our three-dimensional model. All it tells you, though, is one edge length here, if you notice. But keep in mind that our pyramids are regular pyramids, meaning that this shape that we can see as the base has all four sides, 1, 2, 3, 4, that are going to be equal in length. So if they only label one edge, don't fall under the misconception that you don't have enough information. All of those edge lengths would end up being 5 inches long. And then we can see our net here on the right, which they have labeled out, and it helps kind of bring home that idea that all the side lengths are going to be the same. And then we're ready to go ahead and find surface area. So surface area, again, is the area of the bases, or I'm sorry, the base, plus the lateral faces, which I'm going to abbreviate. Now you can see it clearly in the net that we have 1, 2, 3, 4 lateral faces. Again, that number of lateral faces, that can be derived from the number of sides on the polygon that makes up the base. The base is a square. Squares have 4 sides. Therefore, we have 4 lateral faces. To find the area of the base, which is a square, we simply take these side lengths and multiply them together. And that square would have an area of 5 times 5. And then plus the lateral faces. Again, it's helpful to determine how many there are. Again, there are 4 of them. So after I find the area of one lateral face, I can simply multiply that area by 4 to help myself be a little more efficient. I'll take 4 times, and then the area of the lateral faces would be 1/2 of their base times their height. Well, the base of any one of these triangles is still 5 inches, so 1/2 times 5 times the height of the triangle, which is the same thing as the slant height you see listed here in our three-dimensional picture, so 5 times 8. As soon as we simplify this expression, we should have a pretty quick way at finding our surface area. So this area of the base would be, again, 5 times 5. That's 25 square inches. And then we're going to have to break this next part down. I'm going to go ahead and tackle the area of one lateral face first. 1/2 times 5 times 8, well, that should be 20 square inches. But again, that's just one triangle. We need all four, so we still need to multiply that by 4. And then 4 times 20 square inches is 80 square inches, plus the area of the base, which was 25. And that leads us to our total surface area of 105 square inches. In our next example, we're going to find the surface area of a triangular pyramid. And quite honestly, these pictures are very frequently confusing to quite a few people. So if you have a little bit of difficulty telling what's going on here at first, don't worry, you are not alone. And it might be helpful for a lot of us to actually see what the net of this pyramid would look like. So let's see that. So when we lay out all the surfaces of a pyramid, you have our triangular base. Again, we knew that would be a triangular based on the name of the pyramid. And then all the lateral faces, which are always going to be triangles on a pyramid. But once we can identify that, we can start finding our surface area by finding the area of the base plus the area of the lateral faces, just like last time, and we are ready to go. Now the base this time is its own triangle, so to find that area, we're going to take a 1/2 times its base plus its height, again, of the triangle. And then we'll go ahead and add to that the areas of all the lateral faces. Of course, there are 3 of them this time, so 3 times their areas, which is 1/2, times their base times their height. Now you'll notice that we have some decimal values here. So again, as I mentioned earlier, having a calculator handy is going to be beneficial to you. If you don't have one, it might be a good time to pause the video and go grab that before we continue. And then we'll start to find some areas. So for the base, we have 1/2 times the base of that triangle, which is actually right here. It's labeled as 10 meters, times the height of that triangle, which is right here, which is 8.7. This gets a little messy with all those decimals. And so that we don't lose track of things as we go, I'm going to go ahead and calculate that area. 1/2 times 10 times 8.7, which is a 43.5, and that is square meters. Then we need to add the lateral faces. Again, there are 3 of those. And then that'll be times 1/2 times their base. Their bases are also 10. It's still one of the side lengths of this base triangle. But that slant height this time is actually 14 meters. So times 14. And we'll simplify that. So plus 3. And 1/2 times 10 times 14 is 70 square meters. And if we have 3 of those, that's 3 times 70 is 210 square meters. And to that, we will still add our 43.5 from the base. And we get a total surface area of 253.5 square meters. So again, a little bit trickier when you're looking at all the dimensions that they're labeling here on the picture. Take your time with these ones. Please make sure that you're focusing on taking 1/2 times base times height, especially with these triangular pyramids. It's an easy step to overlook with all the extra little numbers. But rewatch the video as many times as you need. We're not going to spend a lot of time on extra on your own problems. It is going to be a little bit more beneficial for you to go ahead and get into the assignment. And as always, if you do run into issues you can't correct, please make sure you reach out to me or visit me during tutorials on Thursdays. And otherwise, I will see you guys next time.